At the end of this video, I want you to be able to compare and contrast the Bohr model and the quantum model of the atom, and explain how the Heisenberg uncertainty principle and the Schrödinger wave equation led to the idea of atomic orbitals, not orbits, orbitals. The idea of electrons having a dual wave particle nature troubled scientists. If electrons had are both particles and waves, then where are they in the atom? To answer this question, it is important to consider a proposal first made in 1927 by the German theoretical physicist Werner Heisenberg. Heisenberg's idea involved the detection of electrons. Electrons are detected by their interaction with photons. Because photons have about the same energy as electrons, any attempt to locate a specific electron with a photon knocks the electron off its course. As a result, there is always a basic uncertainty in trying to locate an electron, or any other particle. The Heisenberg uncertainty principle states that it is impossible to determine simultaneously, meaning at the same time, both the position and velocity of an electron or any other particle. Although it was difficult for scientists to accept this fact at the time, it has proven to be one of the fundamental principles our present understanding of light and matter is based on. In 1926, the Austrian physicist Erwin Schrödinger used the hypothesis of electrons having a dual wave particle nature to develop an equation that treated electrons in atoms like waves. Unlike Bohr's theory, which assumed quantization as a fact, quantization of electron energies was a natural outcome of the Schrödinger equation. Only waves of specific energies, and therefore frequencies, provided solutions to the equation. Together with the Heisenberg uncertainty principle, the Schrödinger wave equation laid the foundation for modern quantum theory. And quantum theory describes mathematically the wave properties of electrons and other very small particles. So, solutions to the Schrödinger wave equation are known as wave functions. Based on the Heisenberg uncertainty principle, the early developers of the quantum theory determined that wave functions give only the probability of finding an electron at a given place around the nucleus. Thus, electrons do not travel around the nucleus in neat orbits, as Bohr had postulated. Instead, they exist in certain regions called orbitals. An orbital, again, not orbit, but orbital, is a three-dimensional region around the nucleus that indicates the probable location of an electron. This figure 4-11, which is on page 101 of your textbook, illustrates two ways of picturing one type of atomic orbital. There are more than this type, but this is just one type. As you will see later in this section, atomic orbitals have many different shapes and sizes. At this point, I hope you are able to compare and contrast the Bohr model of the atom with the quantum model of the atom, and explain how the Heisenberg uncertainty principle and the Schrödinger wave equation led to the idea of atomic orbitals.